been more than 9 years since New Horizons spacecraft started its odyssey. On July 14th, 2015, for the first time ever, a man-made object is going to fly by the most remote planet in our solar system, Pluto. More than 4.9 billion kilometers separate us from Earth. That's equivalent to 33 times the distance from Earth to the Sun. From NASA headquarters on Earth, they anxiously await the arrival of the first signals emitted by the probe, the very first images, the first data. They have been waiting more than 9 years for this moment. Nothing can go wrong. Pluto is an icy dwarf planet in the outer solar system, further than Neptune's orbit. Since its discovery back in 1930, it has remained a great mystery for astronomers. Nowadays, we know almost nothing about Pluto. What is its morphology like, its surface, its atmosphere? It's known that both are not very different from primitive Earth, and that there is frozen water. But could any form of life exist on Pluto? In 2010, the Hubble Space Telescope detected some molasses-colored spots in its surface, which some scientists believe may represent parts of the ground covered in the tar of primordial organic compounds. What are those enigmatic spots, really? Another of the great enigmas of Pluto is its giant moon, Charon. There isn't a satellite as big in comparison to the planet it orbits in the whole solar system. The diameter of Charon is nearly half of Pluto's. How was it formed? What is its surface like? Has it got an atmosphere? But Charon is not alone. Between 2005 and 2012, Hubble discovered 4 more satellites: Nix, Hydra, Kerberos, and Styx. The existence of these satellites represents a potential hazard to the New Horizons spacecraft flyby, because the mission flies at a speed nearly 100 times faster than a jetliner. And in any case, if any of them were in its flight path, there wouldn't be time to maneuver. But New Horizons' voyage doesn't end up on Pluto. It will go on towards a very unknown and dangerous zone in the solar system, the Kuiper Belt. In fact, Pluto is just the first Kuiper Belt object, which we discovered back in 1930. The Kuiper Belt holds tens of thousands of icy rocky bodies in the outer edge of the solar system. They are really the fossil relics of the formation of the solar system. This is the source of many comets, and some of them could have brought life into the Earth millions of years ago. Maybe New Horizons could help us to know more about how life came into Earth, to know more about our origins. We're about to complete a journey that began more than 9 years ago, a journey to the furthest confines of our solar system, a journey that will finally bring us close to one of the most mysterious and enthralling planets, Pluto. This story really begins long ago. Pluto, unlike the rest of the planets in our solar system, was discovered very late. And in fact, its discovery was quite controversial. In late 19th century, some observations of Neptune caused astronomers to speculate that Uranus' orbit was being disturbed by another planet besides Neptune. Those were the first signs of the existence of Pluto. They were right indeed. Pluto's orbit crosses Neptune's. That is what 19th century astronomers saw. In 1906, Percival Lowell started an extensive project in search of a possible ninth planet, which he termed Planet X. In 1929, the director of the Lowell Observatory, Vesto Melvin Slipher, handed the job of locating Planet X to Clyde Tombaugh, a 23-year-old man who had just arrived at the Lowell Observatory after Slipher had been impressed by a sample of his astronomical drawings. Tombaugh's task was to systematically image the night sky in pairs of photographs, then examine each pair and determine whether any objects had shifted position. On February 18, 1930, after nearly a year of searching, something happened. Tombaugh discovered a possible moving object on photographic plates taken just a few weeks before. After the observatory obtained further confirmatory photographs, news of the discovery was telegraphed to the Harvard College Observatory on March 13, 1930. The discovery made headlines across the globe. The Lowell Observatory, which had the right to name the new object, received over 1,000 suggestions from all over the world. Surprisingly, the name Pluto was not proposed by any scientist, but by an 11-year-old girl from Oxford named Venetia Burney. She proposed Pluto after the god of the underworld. Each member of the Lowell Observatory loved it immediately, and on May 1, 1930, that ninth planet became Pluto. Nowadays, Pluto still remains a great mystery for astronomers. We know very few facts for sure about this tiny remote planet.
We have an artist's conception of what Pluto may look like. I have to tell you, it's very far away. It's very hard to study because of its distance, its faintness, even with all of our modern technology. Everything we know about the Pluto system today could probably fit on one piece of paper. We don't know very much about Pluto. Let me show you the best image we have of it. It's made by the baddest gun we have. This is made by the Hubble Space Telescope. That's Pluto, seen from Earth orbit. And you can't tell very much about it. We don't know a thing now, and a year from now, we're going to write the textbooks. This is a familiar object. This is the Earth, at the same resolution that we currently have for imagery of Pluto. What could you tell about the Earth at this resolution? Almost nothing. Let's look at the true Earth. How could you tell what this planet is really like at the limiting resolution that we have from here? That's why we're sending New Horizons.
We know Pluto is a dwarf planet with a 1,200-kilometer radius. That is, a little less than our moon. In 1978, it was found that Pluto's wasn't alone. There was a giant moon named Charon, which orbited around it. Charon is a unique case in our solar system because it has a 600-kilometer radius. That is half of Pluto's. Comparatively, Pluto's and Charon's diameters put together are smaller than the United States. But Charon is not its only satellite. In 2005, the Hubble Space Telescope discovered two more small satellites, Nix and Hydra. 6 years later, in 2011 and 2012, two new satellites were found, Kerberos and Styx. These four new satellites are much smaller than Charon. That's why we discovered them so late. In fact, it's possible that there could be others. Pluto orbits the Sun once every 248 Earth years, which means that the year in Pluto lasts 248 years. Its orbitable characteristics are substantially different from those of the planets. which follow nearly circular orbits around the Sun, close to a flat reference plane. In contrast, Pluto's orbit is highly inclined and highly elliptical. But Pluto's orbit is also unique because of another reason. Pluto and its main moon, Charon, both orbit around a barycenter, a point that lies outside the body of either object, which is the only known such case in the solar system. But there is another fact that makes Pluto's orbit unique and apparently dangerous. Because between 1979 and 1999, Pluto was closer to the Sun than Neptune. Pluto's orbit appears to cross that of Neptune when viewed from directly above. One can examine the two orbits and see that they do not intersect. Pluto has also been a harbinger of the mysteries that await on the planetary frontier. In 1930, it offered a preview of the icy, rocky objects in what would become known as the Kuiper Belt, a new zone of the solar system recently discovered.
This is something new. It's something that we didn't even really know about until the 1990s, and yet it's the largest architectural structure in our planetary system. Beyond the orbits of the giant planets is a vast region, billions of miles across, populated by trillions of comets and who knows how many small planets like Pluto. It is a revolution in planetary science, so profound that we realize what we used to call the outer solar system, where the giant planets reside, is actually the middle zone of the solar system. It is the Kuiper Belt that is the third zone, the true outer solar system. And within it, a new class of planet, the dwarfs. We didn't know they were there. We thought Pluto was a misfit, and now we see it in context. There are many of them. In fact, more dwarf planets than all the giants and terrestrials combined.
The Kuiper Belt holds tens of thousands of icy, rocky bodies in the outer edge of the solar system. They are really the fossil relics of the formation of the solar system. Objects closely to the Sun have been radically transformed by solar radiation. But way out in the deep, dark regions of the solar system, we see things more or less as they were millions of years ago. The discovery of the Kuiper Belt in the 90s radically shifted our concept of our solar system until that moment. In 2006, the International Astronomical Union considered Pluto an icy dwarf planet, not as one of the other planets of our solar system. Now it is also debating whether recently discovered large Kuiper Belt objects, as Eris or Sedna, which are much far away than Pluto, should be called planets. These Kuiper Belt objects are very heterogeneous.
These guys, and they're depicted here with their satellites in their true colors. They have very different surface appearances, very different compositions in many cases, different numbers of satellites. Who knew the solar system was like this when we all went to school? It is truly a paradigm shift in planetary science, and what New Horizons is doing is flying to the biggest and the brightest, the first discovered, and from what we know, the richest, most complex of these dwarf planets in the Kuiper Belt, to the Pluto system.
But what is Pluto's appearance? What other planet does it look like?
What do we know? Well, we know that Pluto is surprisingly made primarily of rock. It is a rocky planet, 70% rock by mass. It has a fascinating escaping atmosphere.
Pluto is a unique icy world with ranges of very bright and dark areas. Pluto's surface has more contrast than any other planet in the outer solar system. It has a very low surface gravity, about 6% of Earth's, which means that a 70-kilogram person would weigh just 4.2 kilograms. To put such gravity in context, let's say that 70-kilogram person would weigh the double in our moon. Pluto is an extremely cold place. Its estimated surface temperature is about minus 233 degrees Celsius, with strong variations across the surface, which makes it a place that is almost impossible to inhabit. Given this data, a question immediately arises. Could it be possible to find any form of life on Pluto, even microscopic? The odds are remote, because it's minus 233 degrees Celsius practically rule out any possibility of life. Nevertheless, in 2010, the Hubble made a shocking discovery. The Hubble images revealed some molasses-colored spots in the surface of Pluto. Based on closer analysis, scientists said the darker spots may represent parts of the ground covered in a tar of primordial organic compounds, and the bright spots in turn are thought to be related to areas covered in carbon monoxide frost. Is there any chance this primordial organic material holds life? Below 233 Celsius degrees, it's almost impossible for life to arise. Then how can these spots be explained? Sunlight hits the methane and breaks it apart into its chemical components, hydrocarbons. Over millions of years, this process makes a dark reddish-brown oil, or tar-like substance, that sticks to the ground. These darker areas spread larger as they absorb more sunlight and cause additional frost to sublimate. But this is just a hypothesis. New horizons might unveil that mystery.
When I was growing up, we had the privilege of seeing the first orbiter at Mars and the first landers, and then the first missions to Jupiter and Saturn and Uranus and Neptune. And they were enthralling, and they were mind-blowing in terms of the richness of nature. But there hasn't been anything like this yet in a long time. 2015 is your year.
New Horizons is one step further in the space exploration odyssey. As with other unmanned spacecraft such as Voyager 1 and 2, the Pioneer or Apollo missions, there will be a before and after in the space race, because New Horizons will be a pioneer in many aspects. New Horizons is the first mission to Pluto, and therefore the first mission to an ice-dwarfed planet. It's the first mission to go into the enigmatic Kuiper Belt and to study the Kuiper Belt objects. Although there have been just 4 spacecrafts that have reached the outer solar system, Pioneer 10 and 11 and Voyager 1 and 2, these did it more than 20 years earlier and had analysis and communication devices much more primitive than New Horizons has. Voyager 1 had also a very special load, the sounds of Earth, a golden record with sounds and images selected to portray the diversity of life and culture on Earth. This message will be revealed only if there are civilizations advanced enough to travel through interstellar space and decode it. The chances of this happening are remote. It's like a message in a bottle in the cosmic ocean. New Horizons also has its special load as a tribute to the discovery of Pluto, Clyde Tombaugh. A small container of his ashes is affixed to the inside, upper deck of the spacecraft. So in a certain way, Clyde Tombaugh will be traveling to the planet he discovered more than 80 years ago. The United States has led the reconnaissance of the solar system, providing the first close-up look at every planet with a spacecraft. In 1973, Mariner 10 flew over Mercury. 11 years before, Mariner 2 captured its first images of Venus. In 1965, Mariner 4 successfully performed the first flyby of Mars. In 1973, Pioneer did it over Jupiter. In 1979, Pioneer 11 was the first probe to reach Saturn. Voyager 2 visited Uranus in 1985, and Neptune 4 years later, in 1989.
It's going to be very exciting. And it's the first time in a generation since our heroes on Voyager took us to a new planet for first time raw reconnaissance, where we go from a single piece of paper in our knowledge to writing the textbook.
But why did NASA scientists decide to study Pluto and not another planet? There are many reasons that made Pluto extremely interesting. Pluto is a whole new type of planet, neither a terrestrial planet nor a gas planet. It is an ice dwarf, common to the deep outer solar system. Pluto Charon is the solar system's only known binary planet, with implications for atmospheric transfer and for better understanding of how the Earth-Moon system formed. But there is another reason why New Horizons mission became a priority for NASA. We are running out of time to study Pluto. Pluto is now moving away from the Sun in its long 248 years elliptical orbit. There is a fair chance that its atmosphere would snow out onto the surface, and there won't be an atmosphere for its study if we wait too long. So we have to go now or wait another 200 years.
The actual spacecraft is about as wide as this table. Not shaped like the table, but about as wide. It's very highly miniaturized compared to Voyager. It has, through the advantage of being 2000s technology, it has much greater capability for first reconnaissance in terms of the instrumentation on board than we could fly in the 1970s. It's carrying the most sophisticated suite of reconnaissance instruments ever brought to bear on a first reconnaissance flyby in the history of humankind. Cameras and spectrometers, in situ plasma and dust instruments.
The New Horizons science payload was developed under direction of the Southwest Research Institute, with instrument contributions from Southwest Research Institute, Johns Hopkins University, Applied Physics Laboratory, NASA's Goddard Space Flight Center, the University of Colorado, Stanford University, and Ball Aerospace Corporation.
The other thing is the miniaturization in the 7-instrument payload. You know, all 7 instruments that return all those different kinds of data on New Horizons together weigh less than just the camera on the Cassini-Saturn orbiter. And combined, when they're all 7 running with their flight microprocessors, draw less than 1/2 of the power of a 60-watt light bulb.
Given the huge space distances, one might think that the arrival on Earth of the data collected by the probe would take a very long time. Nothing could be further from the truth, because the radio transmission signal travels at the speed of light. When the mission reached Jupiter in February 2007, the one-way speed of light radio transmission time from Jupiter to Earth will be just 45 minutes. And when it reaches Pluto in July 2015, the transmission time will be just 4 hours, 25 minutes, in spite of a distance of 3 billion miles from the Earth. That's why the voyage of New Horizons was so perfectly designed. Such a complex journey involves perfect planning, millimetrically calculated over months by a huge team of scientists. On such an important mission, no failure is allowed, because the least mistake could be fatal and ruin years of work. The adventure is about to begin.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
Speeding nearly 100 times faster than a jetliner throughout its journey, New Horizons was the fastest spacecraft ever to leave Earth. New Horizons crossed the Moon's orbit in just 9 hours, something that took the Apollo astronauts more than 3 days to accomplish. On April 7, 2006, just 3 months later, it passed the orbit of Mars. Just a few months later, it crossed the belt of rocky asteroids that circumferences the Sun between the orbits of Mars and Jupiter. No spacecraft had ever reached Mars' orbit or the asteroid belt so fast before. New Horizons was starting to make history. Till then, the mission was a great success. But a critical moment was coming. The Jupiter approach, its first goal. No spacecraft has ever reached Jupiter so quickly. The two most recent NASA missions sent to Jupiter, Galileo and Cassini, took 6 and 4 years, respectively, to reach the giant planet, while New Horizons reached it in just 13 months. And yet Jupiter, almost 0.8 billion kilometers from Earth, is only a fraction of the distance to Pluto. With its 4 giant moons and dozens of smaller ones, Jupiter is like its own little solar system. It has more mass than all the other planets combined. It's the giant of our solar system. Everything is huge on Jupiter. Jupiter's great red spot, a hurricane 3 times the size of our whole planet, has been waking for centuries. There are still many mysteries to solve on this giant planet. But the main reason for the Jupiter approach was not to unveil some of its multiple uncertainties, but another more prosaic one. Jupiter was a key point in the journey because it accelerated the speed of New Horizons many kilometers per hour, letting it reach Pluto in record time. How? The answer is in gravity assist. New Horizons will dip into the gravity well of Jupiter and slingshot out with more velocity than it had when it went in. This insignificant loss for Jupiter amounts to a big boost for New Horizons. New Horizons received a Jupiter gravity assist on February 28, 2007, when it was 2.2 million kilometers from the planet. The flyby over the giant planet increased New Horizons' speed by 4 kilometers a second, which is equivalent to an increase of 15,000 kilometers per hour. After that maneuver, the final speed of the probe was 23 kilometers a second, fast enough to reach New York from Tokyo in less than 8 minutes. That extraordinary speed boost shortened its voyage to Pluto by 3 years. Despite the fact that gravity assist was the main objective in the Jupiter flyby, New Horizons helped to unveil some of its mysteries. The knowledge about the planet benefited from the fact that New Horizons instruments were built using the latest technology, especially in the area of cameras, representing a significant improvement over Galileo's cameras, which were evolved versions of Voyager cameras. The weather on Jupiter was high on the list, as New Horizons instruments probed Jupiter's atmosphere for data on cloud structure and composition. They saw clouds form from ammonia, welling up from the lower atmosphere, and heat-induced lightning strikes in the solar regions, which were the first polar lighting ever observed beyond Earth. Under a range of lighting and viewing angles, New Horizons also captured the clearest images ever of the tenuous ring system of Jupiter. In them, scientists spotted clumps of debris that may indicate a recent impact inside the rings, or some more exotic phenomenon. Movies made from the New Horizons images also offer an unprecedented look at ring dynamics, with the tiny inner moons, Meti and Adrastea, shepherding the materials around the rings. The major moons were in poor position. The aim of the gravity assist maneuver meant that spacecraft passed millions of kilometers from any of the Galilean moons. The mission's investigations of Jupiter's 4 largest moons focused on Io, the closest to Jupiter, and whose active volcanoes blast tons of material into the Jovian magnetosphere.
And then at Jupiter, we had our first bookend where we found its moon Io, the size of our moon, but with 10 times the volcanic activity of Earth and active volcanoes erupting on its surface.
New Horizons spied 11 different volcanic plumes of varying size in Io, 3 of which were seen from the first time, and one a spectacular 300 kilometers high eruption rising above the volcano Vashtar. That offered an unprecedented opportunity to trace the structure and motion of the plume as it condensed at high altitude and fell back to the moon's surface. New Horizons also surfed across the enormous Jupiter's magnetosphere, which is the region around the planet where the magnetic field is strong enough to slow down or even repel the fast-moving charged particles of the sun's solar wind. The side of Jupiter's magnetosphere facing the sun gets squashed by the barrage of oncoming solar wind particles, but the opposite side, the magnetotail, is distended like the tail of a comet. New Horizons journeyed down the magnetic tail for more than 100 million miles. Inside, it whizzed past relatively slow-moving blobs of plasma. Scientists think the bubbles are formed from material ejected by its satellite Io, that is the most volcanically active body in the solar system. After leaving Jupiter, New Horizons went into a long hibernation period that lasted from February 2007 till January 2015. This is what has been called the interplanetary cruise.
First, the technology to hibernate the spacecraft, which we've done most of the way across the solar system. Most of the time, the spacecraft is more or less sleeping, which saves greatly in terms of the wear and tear on the electronics boxes. When we reach Pluto, after 9.5 years of flight, the typical avionics or electronics box on the spacecraft will be less than 3 years old because it's been sleeping most of the time.
New Horizons crossed the orbit of Saturn on June 8, 2008, and the orbit of Uranus on March 18, 2011. But that same year, a totally unexpected problem arose that could have endangered the mission's success. In 2011, the Hubble Space Telescope discovered the 4th moon of Pluto, Kerberos. Just 1 year later, on 2012, it confirmed the existence of a 5th satellite, Styx. Those new moons became a potential hazard to the success of New Horizons. The mission planners started contemplating the possibility of the probe running into unseen debris and dust left over from earlier collisions with the moons. Everything had to be calculated precisely. A study revealed that the possibility of a catastrophic collision with debris or dust is less than 0.3% if the probe is to continue on its present course. If the hazard increases, New Horizons will use one of 2 possible contingency plans. The so-called safe haven by other trajectories. The probe could continue on its present trajectory with the antenna facing the incoming particles, so that more vital systems would be protected. Or it could position its antenna and make a course correction that would take it just 3,000 kilometers from the surface of Pluto, where it's expected that the atmospheric drag cleaned the surrounding space of possible debris. On August 24, 2014, New Horizons spacecraft traversed the orbit of Neptune. But on that very day, 25 years ago, something happened in Neptune that went down in history.
That exact day, 25 years ago, that Voyager 2 flew by Neptune and made fabulous observations of a brand new world.
After passing by Neptune's orbit, the interplanetary cruise of New Horizons had ended. It started the crucial moment of the mission, the Pluto encounter. It had been more than 9 years since it was launched from Earth. It had traveled an incredible distance of more than 4.9 billion kilometers, a distance hard to conceive of by the human mind. The big moment has come. New Horizons is approaching its main goal, Pluto and its giant moon, Charon. The space odyssey is about to reach its climax. This is a historic moment, equivalent to the arrival of man on the moon, the entrance of Voyager in interstellar space, or the landing of the Philae robot on the comet. The first images of Pluto from New Horizons were acquired between September 21st to 24th, 2006, during a test of the LORRI. The images, taken from a distance of approximately 4 billion kilometers, confirmed the spacecraft's ability to track distant targets, which is critical for maneuvering toward Pluto and other Kuiper Belt objects.
Put it in your calendar. We'll be there on Bastille Day, Tuesday, July the 14th, but the encounter actually begins in January. And all the way from January into May, we'll be navigating on the Pluto system, making environmental measurements of the heliospheric environment, dust and plasmas, where Pluto orbits. And then, beginning in May, we exceed Hubble resolution, and it will get better week by week until we swoop, diving through the satellite system halfway between Pluto and its innermost moon, Charon, about the diameter of Texas. All the way through the system and back out the far side, where we will look back to study the atmosphere and solar and stellar occultations.
The New Horizons team will spend the next several weeks checking out the spacecraft, making sure its systems and science instruments are operating properly. They'll also continue to build and test the computer command sequences that will guide New Horizons through its flight to and reconnaissance of the Pluto system. The highly anticipated encounter with Pluto will take place on July 14th, 2015. Pluto will be more than 4.9 billion kilometers from Earth, about 32 times the distance between the Sun and Earth. The busiest part of the Pluto-Charon flyby will last a full Earth day, from about 12 hours before closest approach to about 12 hours after. The planned Pluto closest approach distance is about 10,000 kilometers, or closer if the science team desires. The time for a radio signal to reach New Horizons from Earth at that distance is 4 hours and 25 minutes. Timing has to be extremely precise. The team must transmit the signals used for probing the atmosphere 4 hours and 25 minutes before the anticipated Earth occultation time. The entire encounter sequence will be intricately choreographed and precisely pre-programmed in New Horizons' redundant flight computers.
When we were selected to do this mission, it was just lonely Pluto and Charon. And then in 2005, we were lucky to get some Hubble time to look for more satellites. And in the space of an afternoon, the Hubble discovered two, called Nix and Hydra. Later, in 2011 and 2012, the Hubble discovered more moons, which are now named Styx and Kerberos. And there could well be still more. We've looked in the Hubble data sets as deeply as we can with independent expert teams, and we don't see any more moons yet. But on approach, our imagers will well surpass what Hubble can do from 3 billion miles away. And we'll be looking very hard for those satellites, not only for their scientific value, but to make sure that we don't run into harm's way. There can be hazards from debris that comes off the satellites, and we've made, like any good space mission team, we've made backup plans. We estimate that there's less than a 1% chance we'll have to use those, but those plans are now in place, so we're ready for that part of the encounter. And as we make the approach, beginning about in April, we'll be looking very hard for small satellites that may be orbiting close to Pluto or far from Pluto.
In fact, mission operators will not have continuous contact with New Horizons during the flyby, since the spacecraft will be turning various ways to collect data on Pluto and its moons. During the half hour when the spacecraft is closest to Pluto and Charon, it will take close-up pictures in both visible and near-infrared wavelengths. The best pictures of Pluto will depict surface features as small as 25 meters across. Even after the spacecraft passes Pluto, its work is far from done. Looking back at the mostly dark side of Pluto, or Charon, is the best way to spot haze in the atmosphere, to look for rings, and to determine whether their upper surfaces are smooth or rough. Also, the spacecraft will fly through the shadows cast by Pluto and Charon and observe both the Earth and Sun setting, and then rising through Pluto's atmosphere. These measurements will reveal the composition, structure, and thermal profile of Pluto's atmosphere in exquisite detail. However, New Horizons also brings some revolutionary new capabilities to bear. These include temperature and composition mapping capabilities, and a dust detector to pick up tiny debris particles near Pluto. The technology for these latter kinds of instruments was not available when the Mariner and Voyager spacecraft were flown.
We're going to map all of the satellites. We're going to map Pluto itself. You're going to see it in color. We're going to obtain over 1 million spectra telling us about the composition of the surface. We're going to see the composition of the atmosphere. We're going to measure its escape rate. We're going to determine its structure with altitude, look for hazes, look for new satellites, look for rings, and do many more things.
New Horizons will approach Pluto from the planet's southern hemisphere for a July 2015 encounter. The southern hemisphere will be sunlit and the northern cap dark. The spacecraft flies towards Pluto at a solar phase angle of 15 degrees. Excellent lighting conditions for remote sensing.
If we were to fly over the Earth at the same altitude that we will fly over Pluto and look down with our long focal length camera, not on Pluto but on the Earth, we'd have something like this image. This is New York City in the inset. It's too bad it's not blown up a little further, but if you look and you're familiar with New York City, you can see Brooklyn, you can see Manhattan, you can see the Hudson along the one side of Manhattan and the East River on the other. You can see the long green strip, which is Central Park. And if you look closely, you can count the ponds in Central Park. You can actually see wharfs on the Hudson. You can see the main thoroughfares coming down through Manhattan and the shapes of the largest buildings like the American Museum of Natural History. That's the kind of detail that we're going to have in the highest resolution 70 meter per pixel images of the Pluto system. On both Pluto and its satellite Charon, we will see this kind of detail, and I have to tell you, in the history of first reconnaissance flybys, we have never had the capability to do imaging at this resolution before.
We're sure that this mission will reveal new horizons to us in a remote and still unknown area, the outer solar system. Thousands of new worlds are awaiting our discovery, and New Horizons will bring them a little bit closer. After the Pluto flyby, New Horizons will enter into a totally unknown area of our solar system, the third zone, also known as the Kuiper Belt, of which Pluto is just the beginning. The Kuiper Belt holds tens of thousands of icy rocky bodies in the outer edge of the solar system. They are really the fossil relics of the formation of the solar system. The first Kuiper Belt object was discovered in 1992 when David Jewett and Jane Liu found a 100-kilometer-sized object in a near-circular orbit well beyond Pluto. Astronomers found 4 more objects in 1993 and 10 more the following year. Today, there are more than 1,000 known objects in the Kuiper Belt.
There's a possibility of an extended mission for New Horizons. In fact, that decadal survey actually called the mission that we're flying the Kuiper Belt Pluto mission, indicating the importance of flying on beyond Pluto to explore small Kuiper Belt objects. But to explore them, we first have to find them. They're very faint, they're very far away. These are objects that are much smaller than Pluto and probably much more primitive in terms of their chemistry and their appearance. These are objects the size of counties, for example, not the size of planets. They're very faint, and we've been using the largest ground-based telescopes in the world for about 4 years. And although we've been discovering Kuiper Belt objects, none in that region of space, none of them within our fuel reach.
At any Kuiper Belt object, New Horizons would follow a science timeline similar to the Pluto-Charon encounter. Studies would include surface mapping, surface composition mapping, surface temperature mapping, a search for any atmosphere, and studies of any moons around the target Kuiper Belt objects.
So we proposed to the Hubble Space Telescope, which has even better capability for this kind of search, and we're awarded time in June. And the basic search is now complete. Hubble has done a spectacularly good job and has yielded literally hundreds of images of that part of the sky, from which we found some candidates. We don't know if any of them, though, are within our fuel reach, and we won't still for some months, because we have to track them as they move in their orbits to accurately determine where they orbit and how that compares to where Pluto orbits, so we can determine velocity change we have to make and compare that to our fuel supply capability.
2 weeks after Pluto-Charon closest approach, the team would command New Horizons to fire its thrusters and set a trajectory towards the first target Kuiper Belt object and look to reach it within 2 to 3 years. From there, the spacecraft will continue beyond the Kuiper Belt and into interstellar space. New Horizons will escape the sun's gravity and fly out into interstellar space. New Horizons will never return to our solar system. It will continue to travel into the interstellar space and far beyond. New Horizons won't be the first mission to reach the furthest limits of our solar system. In 1990, Voyager already did that. That was the first man-made object to get into the outer solar system. Once Voyager 1 had completed its primary mission and was leaving the solar system, it was commanded by NASA to turn its camera around and take a photograph of Earth across a great expanse of space at the request of astronomer and author Carl Sagan. The camera was then turned off to save power for the interstellar mission that was about to begin. The Voyager 1 took a series of photographs, kind of family portrait series of images of several planets of the solar system. But there was one picture in particular that went down in history. This is the one. In the photograph, Earth's apparent size is less than a pixel. The planet appears as a tiny dot against the vastness of space, among bands of sunlight scattered by the camera's optics. This picture went down to history as the pale blue dot. This photograph of Earth was taken from a record distance of about 6 billion kilometers, about 40 times the distance from Earth to the Sun. What is fascinating about this pale blue dot is the fact that we are aware that we are there, that it is our only home, that there is nothing else in the middle of the vastness of space. The exuberant life that blossoms everywhere on our planet seems extremely delicate from this perspective. This image, along with others of our planet, taken from outer space, has contributed tremendously to building true ecological consciousness in man. New Horizons may provide us with pictures like this one, once it reaches the outer solar system. These images will undoubtedly be snapshots of much higher quality and resolution than those taken by Voyager 1, an unmanned probe that left Earth in 1977 with much more primitive technology than New Horizons. Nevertheless, it will be difficult to surpass all the beauty and the mystery of that very first picture of our planet, of our home, taken from such a remote place. Carl Sagan was shocked after watching that picture taken by Voyager 1. This is what he wrote soon after. From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The Earth is the only world known, so far, to harbor life. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.